Dear students, so here is a question of the day 1. This week topic will be work power energy. So this week we will do good questions of work power energy. And today I have chosen a very important and popular question, beta. है ना? So that is dumbbell sliding question. This question you will find almost in all JEE advanced good books, right? So any JEE advanced good book you are solving, then you will find this question there in some form, right? So it is a very important question. So first see this question quickly, right? It's a doable question also. It's not like a very difficult question. It's a doable question. It is present in Pathfinder also. In Check Your Understanding, this question is present. Okay, so a dumbbell made up of a light rod of length L and two identical balls of mass small m starts sliding from vertical position with negligible velocity as shown on a smooth surface and along a smooth wall. Find maximum speed of the lower ball. So that is the question. So I will solve this question by two methods. Okay. So there are many methods which are present in different books, and I will solve this question by two easiest methods, okay, that are present. So pause this video for 2 minutes, try this question by yourself, and then we'll discuss the detailed solution. Okay. Now see beta, that is approach 1. So basically a multi-concept required in this question, right? So first step should obviously to obtain velocity of one with respect to other, so that we can reduce one variable here only. So now by constant method, what I'm doing, we know for every rigid body between any 2 points on the rigid body, relative velocity along line joining the 2 point must be 0, right? So that is our constraint. So theta angle, so v1 cos theta, this side must be equal to v2 sin theta, that is constraint. Okay beta, so v1 is equal to v2 tan theta, or I can write v2 is equal to v1 cot theta, that also I can write. Okay, and then step 2 is work energy theorem. The lower ball is not moving up or down, so work done by gravity on it is what, 0, and the upper ball is moving down. Okay, so at any angle theta where we are thinking that velocity is maximum, so here the upper ball, its height is L sin theta, initial height was L, so only gravity is doing work here. So work done by gravity is mg into L minus L sin theta. So lower ball is not moving up or down, rod is light only, no problem. So net work done on the system, means on dumbbell, is this only, is equal to change in kinetic energy, right beta? So v2 already we have written in terms of v1, so we can substitute here, and then mathematically we can solve these two equations. So then solving these two equations, I will get v1 as this equation, okay, or you can write like this. Now when v1 is maximum, the v1 will be maximum when its derivative with respect to theta is 0, right? So unnecessarily steps I'm not writing here beta. So when this quantity is maximum or its square is maximum, so then we can say v1 is maximum. So I'm taking derivative of a square of this term, right? So by taking derivative, making it to 0, so on solving, what I'm getting, sin theta as 2 by 3 I'm get. Okay, so sin theta is 2 by 3. So sin theta 2 by 3, if you substitute here, what you will get, maximum velocity of the lower ball. Okay, so answer directly we are getting. So as I said, it's a doable question. It's not a very tough question, but at the same time it is very popular and important question, right? Now method 2 beta. So method 2 is our physics method. Just like we solve questions in physics, first we need to do brainstorming, right? And then we can think what we can do. Okay, so if I am doing brainstorming here, so clearly we can say here, so the body point 2, why it is maintaining contact with the surface, because there is tension in the rod, right? So when a normal reaction on it is 0, it means at the same time tension also will become 0, right? This tension is developing in it just because there is a normal reaction. So when tension is 0, then at the same time normal action also 0. So when this tension is 0, at this point also tension is 0, it means its horizontal acceleration will become 0. So velocity of point 1 is increasing just because of horizontal acceleration. So when horizontal acceleration is 0, it means at that point velocity of 1 also should be maximum. Okay. So that is the physics part, brainstorming angle. Okay. Now again, just see here, if you observe a motion of point 2 from point 1 in frame of point 1, if you observe motion of point 2, so these are points on a rigid body, and it means 2 is moving on a circle with respect to 1. Okay, now what are their accelerations? Acceleration of point 1 is 0, obviously. Tension is not there, mg, normal action are balancing, moving only on the surface. So acceleration of point 1 is 0. Acceleration of point 2 is g, because normal action becomes 0, tension becomes 0. So the only force acting on point on ball 2 is mg. So acceleration of ball 2 is g. So acceleration of 2 with respect to 1 is a2 minus a1. You can say it is g downwards. Okay. Now rigid body property I am using beta. So acceleration of 2 with respect to 1, it's a component. So 2 with respect to 1 is moving on a circle, right? So and it's a centripetal acceleration or radial acceleration is g sin theta. And now suppose that system is rotating with the angular velocity omega. The same centripetal acceleration I can write like this also, omega square L. Okay. So that is one thing. The another thing is work energy theorem. The work energy theorem I can write in this manner, half I omega square, or I can also write half m v1 square plus half m2 v2 square. That also I can write, and again v2 in terms of v1 I can put, or in this way also we can write half I omega square. Now we know a rigid body, when it is rolling, there has to be some instantaneous axis of rotation. That is instantaneous axis of rotation. About this point body is performing circular motion about IAR at this instant. So at this instant, moment of inertia of this point mass length is L sin theta, and this ball 2, its length is L cos theta. So moment of inertia is m into L cos theta whole square. So half I omega square. So solving equation 1 and 2, what I am getting? Sin theta, again I am getting 2 by 3. Right? Now once we get sin theta 2 by 3, velocity of ball 1 I can write v is equal to r omega by circular method, circular motion method. V is equal to r omega, about IUR circular motion formula. V is equal to r omega, L sin theta into omega. So what we are getting beta? Same answer we are getting as mathematically we were getting, right? So very important and popular question. If any step is not clear, please write in the comment section, right? So as I said, this question is present in many different books. If in any other book you are finding a more simpler method, then also please share. Okay, right? So thank you bete, enjoy, bye bye.